There are two different types of members in STAAD from the analysis point of view. One is the analytical member and another is the physical member. The analytical member is the one which we use it in the conventional modeling connecting the two nearest nodes, whereas there is a special type of member which we also call as a physical member. Now, the physical member is a cluster of members or is a set of collinear analytical members, and instead one can easily model the physical member by selecting the arrays of collinear analytical members and then right clicking it and form them as a single physical member. Now, there are several use or benefits of using the physical member, and its utilities are very much essential in the steel designer mode and also in the batch mode for the steel design per AS4100 code. Now, here we can see the several advantages of adopting the physical member design approach in Staad.pro. Some of the salient points have been listed here. The detailed approach of the physical member design will be explained with some hands-on examples very shortly. So the advantages are first the automated steel grades based on the section type, automated tensile stress and yield stress based on the plate thickness, then the automated segment or sub-segment design. This segment or sub-segment design is very important feature meant for the physical member design per AS4100 code. The code also coins these two terms for interpreting the unbraced length against the different restraint conditions. We will discuss this further in my worked on example. Then the improved design calculation, improve or we can say improve detailed design calculation. As opposed to the analytical steel design approach here in the physical member design, the designed result would furnish the detailed design calculation, the respective clauses and other different information involved in the calculation of the section or the member design capacity. This is very helpful for any engineer who wants to review the detailed design calculation. Now the next is the option to provide the restraint to the individual flange at the exact location. Now the critical flange may vary depending on the direction and the nature of the loading. For example, if there is an I-shaped section having the fixed end supports and the vertical load is acting downward at the center, then the top flange at the central part is under compression, which is susceptible to buckle laterally, resulting in a phenomenon called the lateral torsional buckling. So this flange on the top part of the section can also act as the element which can take the tension. So this can happen on when the load acts upwardly, that is in the opposite direction compared to the earlier case. So in this case, the lower flange is under compression and hence in this situation, the critical flange has been reversed. And in this case, the lower flange is to be treated as the critical flange. Now, STAT can identify this critical flange depending on the direction of the loading condition and the assigned restraint along the physical member length. So in the nutshell, we strongly recommend following the physical member design approach in Staad.pro rather than the analytical member design approach, as our development team is more focused on the enhancement, development, and the rigorous testing in the physical member design mode as far as the AS4100 code implementation is concerned. Now here in the table you can see few of the design parameters meant for the physical member design or the P member design, and some of them are exclusively meant for the P member design like P brace, which can only be used in the physical member design approach. Here you can see this P brace. So this is the P brace that we were discussing so far. The P brace is you can see the P brace in the design parameter box. Now here on the right hand side you can see there are three boxes. The first one is the brace location box where you can assign or impose or define the different location at where you want to impose the restraint. Then this one is the type of restraint at the top flange, and this is the type of restraint or the bracing condition for the bottom flange. So you can select the type of stain at the different location, brace location, at the top flange and the bottom flange by using these three tables. So we'll discuss more on this subject while we'll work on some design examples on physical member design per AS4100 code.